Right. So we'll go to this water container problem. If you try to solve it, right? And somebody mentioned actually maybe the linear solution which you're looking for may be easier, right? But of course the brute force is basically you pick any pairs and see the volume basically, right? You find the minimum, like you compare here it's 1, right, unit, plus of course minimum 7, 8, minimum is 7, so 7 times 1 is 7, right? So you could compare all of these possible pairs and find the maximum, right? Eventually you store the maximum value. So a couple common things, well, but the insight to make this work in linear, what's the idea basically, what's the approach? Yeah, you start moving, and of course that's the idea, because of course, well, first of all we have to start somewhere, right? So we have to start at the maximum at both ends, right? It's possible there's a solution, right? If it's like, is there both like, I don't know, like 8 or 7 something or something, right? It would be the the natural place to look, because you have possibly this is the maximum length here, right? So you want to look at the maximum height here as well, right? But so you check. Now you have some solution, right? You start here. That's your first attempt, right? So the thing is now, the next attempt is where do you move? Like you have basically what you call 2 pointers, right? It's a 2 pointer type of solution we looked at on Tuesday, right? So 2 pointers, right? Or two indices, right? And we're going to be moving backwards. And the only question is how should you move, right? Which direction should you move, right? Well, let's think about it. We should move, right, to the smallest one, right? Yeah. Right, because that's going to be the limiting factor, right? So we move to the smallest one here, 7, right? Because 8 you don't want to move, right? On, then you have a new, you have a new approach, right? Here, so 7 times 6 again, and it actually doesn't, in this particular solution, it stays the same, right? And then you find, okay, you have these 2 pointers, and you have your next move is basically equivalent. Here it's really easy. You go, you have to move somewhere, right? So, but okay, but let's look at let's implement this. Let's implement brute force, right? Did anyone else manage to get close to the solution? Or was the problem itself maybe not clear? Or I don't know. Maybe not. Because sometimes, of course, the biggest problem is finding actually what do we need to do actually, right? That's sometimes the hardest thing, right? Once you know what needs to be done, well, then things become quite easy, right? Right. All right, where's my algorithms? Here we are. All right, code spaces. So we sort of, we can say, okay, is it greedy approach or dynamic approach? Well, again, as usual, very typical approach in solving, we have some sort of like a state, we're saving the previous, high, we need, of course, some sort of, variable where we store the previous high, which is basically, like a pretty much obvious requirement, right? And then basically we have to proceed somehow. Now, let's see the exercise. I think I had a notebook already. Do I have it here? Water container. I have it actually. I'll call it separately. Water. Hello, good morning. Water container. I'll see what I have previously. Maybe we'll improve on this. Maybe not. And here we have water container. But also, yeah, move. And also need the data, right, for water container. We have it here, right? Downloads. There we go, water and water, right? Okay, let's add. All right, so let's add water. That's our commit. Yeah, always, yeah. All right. Now let's see about So whose solution should I look at?
Well, a funky solution.
Should I spin the wheel? Spin the wheel? Or Jacobs?
You can check both solutions.
Okay, we'll check both. Right. All right. So this one here. This is actually okay. Little link.
Yes.
Little link. Okay.
I implemented mine in
Go. All right. So then the thing is, of course, do I have Go compiler in this notebook?
You can install
You
it.
can install. I don't think I have.
Oh, you do?
I do. Right.
Which version though?
Let's check. It should be pretty recent. Well. Wait. What's happening? Why don't
Without two,
just one?
or without the dashes. Just Go version.
Oh, all right. Oh, sorry. See again. Yep. 2, 1, 2, 3.
It's
That's
good.
pretty decent. That's
Yes.
pretty decent. Yeah. Okay. Right. So we can build it actually. This is the next semester. We'll do some Go as well, by the way. Right. So we'll do programming languages. Go is one of the languages we'll cover. Right. One of the newer languages. Right. But now let's see. Can I actually see? But I just need. There's nothing. Yeah. That's all it. Right. So go build buckets. Right. Let's do it. Let's check.
I also created the release so you can download the binary
Okay.
directly.
All right.
It's you see there are tags.
Yeah.
Higher, next to the branch main tab.
Branch.
Yeah,
Tag.
so-
I see here. Yeah. Okay. All right.
There
Branch.
should
Branch. So
be-
there's a binary, which of course is for Linux, right? For Ubuntu, right?
Yes.
Okay.
You are on.
Yeah, I am, of course. But let me try compiling it, right? Let me try compiling it, right? Right. I don't trust your binary. I don't know what you put in
Okay,
there,
okay.
right?
Maybe I just
Yeah.
printed the result.
Yeah. Let's try to build it. Let's try to build it. No, there's just like I said, it's
Did you clone the project at first?
yeah, well, no, I didn't clone it, right? But then I have to, God, then I have to. It's gonna be interfering with this byte, right? Because right now, git status, right? I don't want to do it here, right? So where am I gonna go? You know, I gotta do it like sub. I don't want to mess with repository inside the repository. It's a pain, right? I could, right? But I mean, if I do it here, right? You know, that's not mine, right? I guess I could workspace. Maybe I could. I suppose I could try. Let's try it. Okay, let's clone it. Let's do that. Okay, sure. Why not? Why not? Why not? Why not? All right. There we go. Where's my code? Not code. Local. Yeah. Let's do. Oh, come on. I not check. Come on. Oh yeah. Okay. Retry. Hello. Okay. Yeah. This is it. Okay. Right. Let's see what happens. Yeah. Okay. See bucket challenge, right? And this is go build and buckets or something, right?
Yes.
All right. Let's see. Yeah, let's do it. See, it builds. It should be fast. Go usually builds very fast, maybe because it's been okay. Yeah.
Actually, from my experience, the building process is not that fast.
Yeah.
It takes like 10 seconds.
Yeah. Well, I'm comparing to C++, of course, right? But, I mean, comparing some bigger projects, right? So, okay. So we have this big, how much? No, not a big binary, to something. Okay. So it works. Let's take. Let's check out the code, right? So this is cool.
Yeah.
Let's check out the code. I need to go actually up then, right? Let's see. How can I? Well, it's here. Can I go up? Actually, now the good question is I don't see it here. I guess I'll have to go. Could I open it up? Let's see. Can I think I can do this code main Go. I think I can do this. I think. Let's try this. Yeah, I can. Okay. Yeah, I can do this. All right. So again, so this is for those who's first time seeing Go extension. I can install it. Why not? Right. Alright, install it, why not, of course. Alright, so again, we'll talk about the imports. So we have the calculated bucket, right? A function, right? On the best value, right? I guess you need something to store something, right? Let me make this a little bit bigger so you can see this, right? And again, you can see the code is, well, I mean, Go is meant to be easy, right? And array length, and you have these two pointers, exactly, right? You start going through, again, syntax is not that different, right? Of course, you have the assignment operator here, right? Basically, but you know, for loops, right? So you keep checking, basically, right? And you need to, of course, calculate this, right? And if you see this, right? So you basically, the only thing is decision where you go, right? So if the end pointer is bigger than start pointer, basically, right? So the value, basically, right? Position, right? So you increment the start position, right? And while, how do you quit? Where do you quit? Lane.
Just for loop.
Okay, yeah, okay. So eventually, so your pointers just go like this, right?
Yeah.
You don't stop. You don't have early exit, right?
No.
Well, yeah, right. Okay, so
Maybe, yeah.
you could quit early, right? If the pointers overlap, right? I think you could.
I quit when they're equal.
Yeah. So, but okay, it's, you know, just double the work, but that's okay, right? Okay, right. So that's the unread values, right? Nothing too difficult. I mean, like I said, assuming, you know, once you know the Go syntax, right? Read file, split, right? All those things we already know, right? Again, Go is interesting. You only have 4 loops, by the way, right? So range, right? And yeah, you convert it. This is for reading values on your main, right? Parse and yeah, you split by new line. The only splitting was because you had 2 different ways of splitting, right? That was the only thing, right?
Yeah. Well, I mainly did with the lengthy file. The
Yeah.
other one I just tested whether
Yeah,
it
okay.
works. So I decided why bother.
Yeah, okay, got you. Okay, now let's see how it works, right? So there was arguments.
Yeah, there was in GitHub there should be.
Yeah. All right. So
Let's go.
yeah, something like this. Pass. You have a pass parameter, right? Or
Yeah, the one for Linux.
yeah, pass. Yeah, of course, it's binary. So buckets, right? And pass or p doesn't work, right?
Yeah.
Just pass and we'll do water on 1000, right? So let's take a look.
Let's see.
90, that's 9 million something, right? So did anybody else get this? You got the same one, right? Right. So we'll see now, of course. Let's see how we arrive. So where the values are, right? So this is kind of like nice big number, right? Like kind of like have some zeros there, right? So that implies there's at least one of the parts. Well, there's 0, or maybe it's 2 by 5, maybe I don't know, or 25 times 4. I don't know. No, 2 times 5, something like maybe, you know, right? Because you have 0 at the end. So it will be interesting to see where actually the answer is, right? So, okay, but yeah, again, so this is a 2-pointer solution. Now, let me look at the. It looks good. So the other one wouldn't work, right? The water won't split.
No. Like
Yeah, it's because the split here. I think it's the split. It's explicit. You mentioned new line right here, right? You can't just do white space, any white space, or can you with this function, right? Let's see. Okay.
Yeah, well, I know I could have used buffer reader.
Yeah.
Buffer reader. I don't
If
know
separator is empty, splits after. Okay, yeah. So that's if it's empty, it's not like a Python split, which is splits by any white space. By default, the Go split splits by character, endpoints. So like just like this basically. So not what we want. So I don't know offhand how could you provide both. You want new line or white space. You want to do this something, but I guess I don't know the syntax for this. All right, so you want to split by multiple choice, like regex basically, right? So okay, but yeah.
Are they not chainable? Like do another split and then?
Yeah. So okay. So can you split maybe twice, right? Because it's string array, but this returns.
Then you would have a 2-dimensional.
Yeah, you're splitting twice, right? So you need to split basically in this case, to. Yeah, this would be interesting problem to solve. Maybe we could see if something. I'm sure there should be a relatively nice way of doing it. I mean, it's still going to be a little bit wordier than Python, of course. Go is a relatively easy language, right? It's easy language, right? It's meant.
But error handling is better there.
Yeah, but of course in Go is famous. You always have to handle errors, right? You always have to handle errors, right? You're going to be writing a lot of this type of code, a lot of code. But again, that's for next semester, right? So, all right. So very good job. But let's see the Python because are you working on Go at work or?
Yeah.
Yeah. Because it's like I said, it's a if you need to compile a language with garbage collection, it's a pretty good choice, right? I mean, the only downside, of course, it's basically if Google decides they don't like it anymore, then the support will dry up, basically, right? That's why it became so popular, of course.
Yeah.
Yeah.
But as far as I know, it's very rapidly growing.
Yeah.
So I don't see that.
No, it's not. Yeah, it's not going to happen. Again, it has good tooling, right? Again, compared to some other languages, there's some good tooling, right? But there's recently, again, since we are talking about this, there was recently. Let me see if I can find it. I think I'm going to find the link. Why Go is not my first language, something like that. Let me see if I had it here. Let me see if I can find it. It's like a couple days ago, somebody complained about Go. Somebody who writes a lot of Go, actually, right? So, I mean, but this is the funniest thing. Lies we keep ourselves to keep using Golang. Lies we keep telling ourselves to use Golang, right? Yeah, this one here, but this is like 2 years ago actually, right? So, yeah, I want to go Mr. Golang's wallet. So, of course, it's like any language, right? There's a famous saying by C++ creator, right? There are only two types of languages: languages that everybody complains about, and languages nobody uses, right? And it is basically true, right? I mean, people complain about Rust as well. I mean, every language has some negative things, right? So, yeah. So he has some valid complaints about why Go has some problems. Like I said, I personally, what I don't like about Go, like if I want to, I don't know, parse JSON or something, right? It's not as nice as in Python because you sometimes don't have the structure as well, right? And there's some things. I mean, Go is not kind of avoids the object-oriented programming thing, right? So it's kind of
that is very interesting aspect. And at work, I think I haven't really touched upon like making classes. I've only made structs.
Yeah, you have these interface things and basically So, but of course, you think about it. People who made it basically they are heavy, not C++. They were C programmers, right? Rob Pike, a major figure in C programming, right? From 1970s, and also I believe what's the name? One of the creators of C also is there. So basically, they sort of say, okay, we don't like what C++ is doing. We want a language which people who have used Java and Python, basically, right? Who know, in school, as you learn, right? You learn Java and Python, basically, right? In most schools, they could get up to speed in maybe a month and start doing productive work, very quickly, right? If you want to do this in Rust, no. Or C++, same problem, right? To do good work in C++ or Rust, it will take you a while, right? Go is easy enough, right? So, but yeah. So let me see what he doesn't like. Okay. So he didn't like the things like there's no sum types, right? Some data structures, there's some memory misalignment problems, right? No operator overloading, things like that. Also, what's interesting is the lack of support for immutable data, right? That's the only one I kind of more agree, but I will have to investigate this more because it's kind of nice if you can have really solid structures which are not immutable, which are immutable, right? Not changing, right? Here, with Go, it is actually apparently it's very easy to mutate everything, right? So. But okay, so but it is really not a problem, for most people, right? So, okay, we'll talk about Go later on. But now let's look at our other solution again. So you have a very similar solution just in Python, right? Yeah. Because again, the only issue is, like I said, is figuring out why we should move, like which pointer should we move, right? So extensions Go. All right, let's see. Okay.
You should see the out from.
Do you mean?
You should change directory.
Yeah. Oh yes. Yeah. Come on. Yeah. Okay. That's cool. We have Go. What else do we have? So G++ is included also, of course, I suppose, right? Right. Yeah, G++. What else? Java is included? I don't know. Yeah, Java is included, right? What else could we check? I don't know what Rust. What's Rust compiler? Rust C, I think it was Rust C. I forget now. Was it? I don't remember. No, I forget now. But maybe it's not included. You know, you can't include everything, right? But at least all the major languages, you know, all the, you know, also the build systems are included. So maybe like the Node version is included. I don't know. Yeah, Node's included, right? So yeah, yeah, it's you know, the machine's pretty much ready to go, right? So how much do we have? Space. We have 2 cores. We have 8 gigs of RAM, right? This is a cheap. I mean, I could get something more expensive, right? But this is a free, you know, almost free. I mean, I could leave this running for basically half a month and not pay anything. So this is basically F10. Yeah, so F10. Yeah, okay. Now, all right. So we go to where's our materials, right? Now, okay, so this. Oh, there's 3 assigned. Somebody else submitted. Very good. Edwards. So let me check this one. Yeah, so same thing basically. Like pointers, move the shorter pointer, right? And do the same thing. Again, so one thing again, going back to Go. What's the good thing about Go, of course, is you know, it's compiled. So you build a binary, and you can just put it somewhere, right? You solve the grammar problem. There's no more grammar problem in Python, right? You don't have to worry about giving, if your programmer wants your Python code, you know, how do you deploy it on her computer, right? It's a bit of pain. Right? Yeah, so.
Create a Docker container.
Yeah, well, yeah, or, you know, like PyInstaller does, you just have to basically ship Python with it, like in a single file. It's a pain, right? With Go, you actually compile it, you can give a single binary, basically, and it should run. Right, okay. Now, so enough Go. So, now this is, let's do one more. So I will make a new file, water container file 24 by MB, right? Yeah. Right. Code. Okay. All right, I'll build main and we can run it basically, right? I'll run it here. Let's run it. So it runs both, or what? Let's see. Or oh, it is. Oh yeah, it's doing this. Oh, it's the big one, right? And it returns. Okay. Well, yeah, it's gonna. Okay, we'll see it, right? Quick. Okay. Excellent. 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 All right. So let's do this main. Yeah, we can do an argument here, right? File. Yeah, I will do this. Oh yeah, I should. Oh, you can split by anything, right?
First,
split
it by lines, and
yeah,
then each line split by spaces.
Okay, but you don't need this command. You can just make it like this.
Yeah.
That'll work too, right? All right, fpass, and of course here fpass. All right, and I will do this here. All right, let's see now. Yeah, it should work. Yeah, okay, and now we can check the other one, right? See if this works. Water, just water everywhere. Yeah, 112, right? Okay. So now how could we find the locations of this, what's happening? We could basically return the pointers, basically, right? Here it will stop, right? Almost stop, right? We have this max area. Okay, so when we do this, right, we can also find the locations, right? You know, we could stop here at this moment we have start pointer, end pointer, right? We can, this is a place max, right? But yeah, okay, so you max area, right? I guess we have to add the if here, right? If you have to make an improvement, right? So when you're doing this area, right, mean heights, yeah, very good, very nice, efficient code. We would like to save the position here. Let's see, can we somehow, how could we make it without, well, I guess we'll still need to do the if. I guess we'll have to transfer this to an if code, right? If we want to save the pointers.
Likely, yeah.
Yeah, I don't think we can do any tricks without here. This nice, you know, I hate to change the code, right? It's nice, clean, right? Nice, clean code, but well, if you want the pointers, right? So, you know, start pointer, so max area. So we'll add two more state. You know, we'll add state that we want to return. So, you know, first index, you know, start index, you know, start winning. How should we call it? No, how are we going to call it? Best start, right? Zero, yeah, which is start pointer, basically start pointer, that'd be better. On best end is of course end pointer. So now the question, how do we need to update? Now we need to check, right, yeah. Because here, if we keep updating, right, because remember this problem we need to do if, right? So we will, right, we need to update area. This is the actual area, right? Okay, so that stays same. So now we need to check whether new area is bigger, right? So if, right, exactly, right? So best start, best end, and of course what we're gonna do, we're gonna return it, right? Best start, best end, right? Okay. Wait. What happened? Oh yeah. So 1 and 9, 8, 9. Okay. So this means if you check our water, so this here, you skip this one, I hope, right? Yeah, you skip this one, right? Yeah. So this one here, right? And somewhere here is 9 something something. What was it? 999? No.
989.
989. This one, no, this one here probably. Which one? Right. Let's see. Wait.
Likely the 2400.
Yeah, I think so. Yeah, let me double check again. So we keep improving. This one here probably, right? Or this one here, let's see. No, this one here, I think. No, wait.
Why not 9?
Yeah, because you can keep going, right? This is kind of weird.
Let's do a manual check.
Right. Yeah, let's do a brute force, like 1000 by 1000 million checks, right? Right? Yeah, let's do brute force solution, right? I should have a brute force, but okay. All right, let's do a brute force. Let's write the brute force solution. We simply check all pairs, all possible areas, right? Define get max area, brute define get max brute force height. Okay, so you see two loops, quadratic immediately, right? So we have the heights, area, mean heights, if area max, so the same thing. Return, best start, best end. Okay, right? Simple code, but bad, right? Simple but bad code, right? I mean, not efficient, right? Quadratic, so quadratic. Yeah. Okay, let's double check. Do we have the heights now? What I would do is, of course, do you have the function to get the file? Oh, you don't. You should probably make, yeah, get function to do this. We have the height. This gives you the height, right? So let's see. Yeah, you skip here, right? So you skip the one line, right? Skip the first line. Skip the first line. Keeps the first line, right? Okay. Next iterator, right? So it should work for line. Get heights if they're separated by. For value in line strip, right? Yeah, you should get either one line, right? Or basically, you know, or none, right? Yeah, no, it works. Int value, yeah, everything looks good to me. Okay, heights. So let's make also function to get heights from file, right? Let's write the function to get heights from file. We need to skip the first line since that is the number of heights. Okay, right, so something like this, right? All right, so heights, yeah, that's the same one, right? Okay, now let's read it. So heights, right? So this is all our functions, right? So heights 1000, right? Len, no, I don't have that. Print. We have, right? We have 1000 height. Okay, looks okay. Now let's get solution, right? Let's get brute force. Let's get brute force solution. Time, I don't want time. Okay, so solution tuple. What do we have? We have the area. You know, area start and right and okay. I guess yeah. Yep. Okay. Unprinted. Pretty quick actually. 1 and 899. So let's. This is so bizarre. Okay, so let's see these values. Okay, I'm kind of curious, right? So let's see the values. No, I don't need all the values. So for start and end, right? I'm just curious. Okay, so where did we miss this? How did we miss this? Somehow, yeah, this is a value, right? Correct. This is a big value, yeah, which makes sense, right? So, right, and somewhere we have the other value. What was the other value? 913. So obviously it's 913 times 913, right? 9130 times whatever the distance is, which is 988, right? 988. Makes sense? Let's double check, right? So area should be start minus end times yeah, mean right. Yeah. Correct? Yeah, it is which should be, right? Makes sense, right? Okay, let's double check one more time and then we can, sometimes you know you don't trust yourself. So 9, where was it? Oh, we missed this. This one here, this, okay, yeah, because we had the first line, so yeah, that's correct answer, yeah, so 9130. Okay, it makes perfect sense, of course, right? These are pretty big numbers, 9,000 something, right? You don't want to go here because then you don't have a good container. There's nothing remotely good in the last values here, right? On the previous 9,000 is probably somewhere here, yeah, right? So this is apparently less, right? This one is not so good, right? Okay. Okay, but so out of all of this what we were doing, to return this, right? So the key insight was the movement. So two pointers, right? Or maybe 3 pointers. Sometimes you have 5 pointers, right? You move different things, right? So again, you avoid this quadratic complexity if you're moving in only one direction. So obviously, eventually, right, it's going to be linear, right? You're going to converge, right? So the only argument is why moving in a single direction is okay, right? Like always, why this works here in this case, that moving, you have a choice between these 2 pointers, which one to decrease, right? You should look at the smaller one, right? The next value, which is like basically if it's basically smaller, you need to basically keep checking, basically, right? Because you don't make an improvement, basically, right? So, does this make sense, this argument? Right? Kind of, right. But of course, again, this thing is like if you have never heard this, and you don't have ChatGPT, or you don't have any documentation, don't have like a cheat sheet or something, it's pretty hard to figure out immediately, right? But again, so what you do this type of problem, right? Again, start with brute force. Again, even though it's relatively might be sometimes a little bit complex, the solution might be a little bit more complex, but and then you can check actually whether your solution actually with these pointers, right? Whether this makes sense. Because what else could you do here, right? And the other insight is of course that you potentially have a full solution at both ends, right? I mean it's a potential solution. If this was completely high right here, right? If you had the maximum height somewhere here, this would be the obviously the best solution, right? Right here. I'll draw some water. Right, this is supposed to be water, right? So this would be the maximum. So then nothing you would do here, right? You keep moving the smallest possible case, right? But it will not make any improvement, right? So, all right. So what else we should take away from this, basically?
But if the two middle rods are almost with the infinite height, then
yeah, of course. The thing is, right? It's possible we have a solution in the middle somewhere, right? Yeah, it's possible we have a solution somewhere like this.
So we can't really do an early exit.
No. No. I mean, we have to check we have to meet. Yeah, we have to meet. Right? We can't. This doesn't mean right. We can't exit immediately. No, we have to check our pointers have to meet. Right.
So it's always.
We always have to go through linear. It's always linear.
Yeah.
Worst case, always linear, right? Because you don't know, right? I mean, you can't just exit O1. There's no O1's best case scenario. It's always linear, right? So yeah, it's possible because in middle you have two huge skyscraper, right? Full of water. I don't know, right? So, and the rest is just one, something like this, right? Something like this. And you have this huge, right? It's possible. All right. So thank you everyone. We'll see you guys at 11:10.